Now, before we start the next example, we're going to talk about rigid transformation. So notice, guys, that I went from AB to CD and I just kind of moved it. Rigid transformation means that it is just moved. Nothing changed about the size or shape, just the position. Okay, position can change, but size and shape cannot for congruence. Okay, so congruent have the same measure. Okay, see this right here? Congruent segments have the same measure. Congruent, if you want to know the symbol, it's these two equals, and this, like this, okay? This means congruent, okay? You need to be familiar. Congruent means size and shape are the same. That means properties are going to be the same in all those things, okay? So example is if I do something like this, let's call this A, B, and this is 5 centimeters. And I go over here and I do 5 centimeters. Let's just call this Y, Z. Then AB, segment AB is congruent, segment Y, Z. Yeah? Y, Z. Okay? Show that two line segments are the same. So what you can do actually is there is a thing called constructions. So the way we make constructions is actually quite important. So let's get to it. So example, we use constructions. The only things we are allowed to use is a pencil, a straight edge, and a compass. Luckily for me, I have a compass. Okay? If you do not have a compass, this is the time to get one because it will come in extreme handy. Okay? Let's say I'm not looking at mine. I know you might look at the numbers and tell me how long something is. So I'm going to make a length, okay? And let's call this, let's call this EF, okay? Now I want to make a congruent congruent line segment to this along this line. So first I'm going to put point M. And what I do is I take my protractor, okay, and you don't want to poke it through the paper. You just want to lightly put it on, and you want to measure the end point, okay? Now I'm going to do the same thing, and notice I'm just going to go with this. And what you're going to see is we're going to have an equal, a congruent line segment here, MN. So I made a construction, EF, line segment EF is going to be congruent to line segment MN. So you want to make sure your protractor measures the first line segment, and then on the second line, okay, so the distance between 2 points is the length between the two endpoints. Okay, the distance between E and F is just the distance between the points. You already know this, but basically it is the distance formula. So if you don't have an x and y, the distance formula is quite easy. So if you just have 2 points along a horizontal line, so P, which is x1, and Q, which is x2, our distance is going to be the absolute value of x2 minus x1, because distance is required to be, so their distance or length is going to be x2 minus, the absolute value of x2 minus x1, or the absolute value of x1 minus x2. This order does not matter because the absolute value ensures we're always going to have a positive. Okay? Now, there's example 3 is finding it. So if you'll notice, they have these different points, and this is just plugging it in. So, okay? So plugging it in, we can solve for it, and we'll have a good time. Okay? Find the distance right there. Okay, so the key is actually the distance formula is what we're going to end up dealing with. So if we have this in the coordinate plane, y and x, and we have 2 points, A and B, the distance, which in this case is going to be AB, is going to equal square root of, let's say this is x2, comma y2, and this is x1, comma y1. It doesn't actually matter, but you do x2 minus x1 squared plus y2 minus y1 squared. Okay, you need to know this distance formula, plugging in the proper terms. Okay, irrational number just means we're not going to get a competing decimal with it. Okay, they show us in the next page, and then they give us 2 points, and we're solving the distance between them. Okay, you may leave it as the square root or have it as the approximate decimal. Now the clear thing is, if you want to know what decimal you're going to do, read the instruction. If the instructions say hundredths, you do hundredths. If it says tenths, you do tenths. If it says nothing, just do tenths. Okay? If it says nothing, you can do tenths. Or leave it as square root. Okay? Okay, we're not going to do any of these fraction problems, primarily because we will talk about them later. So if you want to look at them, you're just plugging them in. So in this case, this is -3 minus 2 squared, which will give us -5 squared. And then -2 minus 4, which is -6. -5 squared is 25, plus 36 is 61. Okay, and they give us an approximate. Now, again, why is it in the hundredths? It's not necessary. Okay? And then there's a practice problem here. So the end zone 0, 0, and then they give us 2 points, and along the line, we are finding the distance. So again, 60 minus 20 squared, which is 40 squared, and then 20 minus 5, which is 15 squared. So 40 squared plus 15 squared is going to be 1,825. And then they give us the decimal place. Now, is there in the instructions that you should go to limits? No. So you do not need to worry about that, okay? And then they say, check it. You don't need to do that. That's ridiculous. Okay, so today is all about distance. On Monday, we will cover midpoint. So today is going to be a shorter lesson. You are not required to write all the notes. You're required to write what you need to know. And I would say the main point is, do you know congruence? Do you know how to make constructions? Okay, thank you so much. We'll see you guys in class.